Hi, good morning, everyone. Really appreciate you joining in. This is the first seminar that we'll be doing as part of the Virtual Brewers Conference. So, good morning and good afternoon, depending on where you are. So, my name is Kevin Weaver, President of Brewmation. I'm going to be bringing to you here a bunch of information. We're going to talk about brewing automation and controls. Just a quick note, you guys can put some questions up on the right-hand side. I see someone already said hello from Brazil. That's amazing. How's everybody doing? So this is great. We're going to get right into it here. We got about an hour, and we will go ahead and go through everything. Perhaps answer a few questions along the way. When we get to the end, there will be a Q&A. So welcome everybody, and we'll get started. I'm going to take my video off just so you can get a better screenshot here. All right, so a couple of things that we're going to do here. We're going to, we've already done some introductions. I'm seeing all sorts of hellos from anywhere from Finland, Canada. I see a San Antonio, that's amazing. So we even got Long Island, New York, so close to us. But again, good morning, everybody, and good afternoon. So what we're going to go through here, a couple of things. We're going to talk about art versus science. We're also going to talk about the automation as it applies to each step of the brewing process. And then we'll get into some levels of controls. So getting right into it here. So when we start talking about the process, and this is so true, I'm not sure really if an ancient brewing proverb came up with this, but it's an amazing statement that anyone can brew a great beer, but a good brewer can brew it again. It's very true. I know for myself that back a long time ago, too long that I'd care to admit, when I was first starting brewing, I made an amazing Pilsner. I mean, it was just fantastic and everyone loved it. And I don't mean just love it because, yeah, Kevin, nice beer, but really it was a really good Pilsner. And then after that, I tried to brew that Pilsner again. And I made so many bad beers trying to recreate it. It was just terrible. So, you know, we all have that appreciation that you can come up with a good beer, but that repeatability is actually key. Obviously, if you have your own brewery and you're professional brewing. So my own story, that's kind of where the whole automation thing came to be. So we've been working on it for quite a while. So of course, the art of brewing. And it's worth bringing up because when we start talking about automation, a lot of people fear that they're going to lose the art, they're going to lose the craft. But we'll get into that a little bit. Obviously, the art of brewing, it's a pursuit of a goal. You have a goal, you have a vision, what you want your beer to be, what you want it to taste like, what the impression, the whole craft behind it. You start exploring ingredients, flavors, styles. You're perfecting and developing your recipes. And obviously with the result, you want to create something new and you want to put your stamp on it. And automation doesn't have to get in the way of any of that. In fact, it's going to help. And that's where the science of brewing comes in. When we look at the science of brewing, we're looking at the control over the entire process. As we talked about just a bit ago, the ability to rebrew a beer, the ability to tweak a process to parameters that achieve the goal. And obviously it's going to enable you to explore flexibility and creativity. So in other words, you know, when you go and you make that beer, just like I made that Pilsner, you want to say to yourself, you know what, how am I going to recreate that? What was my exact temperatures, what flow rates that I have, all of that. And the same token, you know, you may not get lucky and brew that great beer the first time out of the chute. You might find that it's a little bit too sweet, a little bit too dry, so you want to adjust your temperatures, but you need to know where you were for that time frame. You know, was it a design flaw or was it a system flaw? So that's really where that science of brewing comes in. When we look at that, oops, I think I went the wrong way here. Automation facilitates the science, and science facilitates the art. So this is a great graphic here just to kind of explain that. Everything mixes together. Automation certainly does not destroy the craft. It just enables you to be more creative, more flexible, and more repeatable.
John Kalinowski here. I'm just jumping in. It seems we lost audio for Kevin. Give us a minute and we'll figure that out. All right, can you guys hear me? This is John here. Great. Seems Kevin's having some technical difficulties on his end, so I'll jump in here. And I think where we left off, Kevin was talking about how the automation facilitates the science, and the science is what enables you to practice the art. And so what does automation look like in a brewery environment? And what we're going to do is kind of step you through the different vessels, the different processes in the brew house. So starting with the hot liquor tank, obviously one of the most important aspects of brewing is getting your temperatures and hitting all your temperatures. Getting your strike water up to temp so that you can hit your mash temp. And maintaining that set point is critical to the brewing process. The strike and mash temp consistency is what will enable you to rebrew that beer, that Pilsner that you're after. And having that temperature control will help you to avoid overshooting. So, by the whether it's a PID controller or just a set point controller, avoiding overshoot on on heating up your strike water will save you time. And we'll see at the end how all of these aspects of automation can shorten your brew day. And it will enable you to have predictable results. So here we're seeing the heater controls, and this is just kind of a snapshot of one of the control panels that we build at Brewmation. And whether it's electric, steam, or direct fire, we can automate that heating process. So in the case of electric, we'd be controlling the power going to the elements. In the case of steam, we'd be controlling the valve that's sending steam to your jacketed tank. And in the case of direct fire, we can control the burner output, with a constant feedback loop of measuring the temperature in the tank and then either turning on this electric, steam, or direct fire to get us back up. We also have a preheat timer, which is a really nice feature. And if you're listening in on some of the other webinars, you'll hear more about that. But the preheat timer allows you to set the hot liquor tank to come on, for example, at 2 in the morning, so that when you get to your brew house, your liquor is all heated up and ready for strike in. And this is particularly true on electric systems, but can also be the case on steam and potentially even direct fire, depending on your local regulations. So it allows your strike water to come up to temp before you get there, but also allows sort of the temperature of the liquor in the vessel to equalize with the vessel itself. The tank itself, may be bringing down the temperature of the strike water. So having that time to preheat allows you to hit the ground running when you get into the brewery in the morning. We can also include circulation so that you don't get any dead zones or cool spots in your HLT, especially with larger HLTs. We can see a temperature gradient from the bottom of the tank where the heating elements are to the top of the tank. So by having a circulation pump, we can ensure even heat distribution throughout the HLT, which will make it easier to dissolve your water additions, your salts. And then we can use an automated switch to strike over from the recirculation, or to switch over from the recirculation to your strike-in when you're ready to start brewing. And in that same circuit, that same pipe work, we can include a flow meter that's measuring the water flow from your HLT into your mash tun to ensure that, to measure the volume and make sure that your ratio of grain to water is what you're looking for. And then these last couple points, not depicted on this particular control panel, but the blending of hot and cold water. A lot of folks are using either a CLT, a cold liquor tank, or city water, and mixing it with the hot water. And the purpose there is so that you can heat up water to temperatures above what you want to strike in at, which will then enable to use that water as, for CIP or for other parts of the process. So it allows you to maintain a higher liquor tank temperature and then blend it down with colder water to hit your strike temps. And so we can automate that process as well, the mixing valves, to achieve the consistent strike temps, have less operator interaction, and the ability to auto switch over from from your cold liquor tank or from your city water to run through your plate heat exchanger for knockout. So that's the HLT. Moving into mashing, and what we have on the screen here is a visual of sort of one of our touchscreen interfaces. This happens to be a steam system, but we have all the controls at our fingertips. This is the controls for the brew house. So focusing on mashing, we can automate the mixing and blending process, the grain conveying rates, and ensuring that you're getting your proper grain measurements into the mash tun. And we have a number of sort of automated processes and pieces of equipment that will weigh out the grain as it's being fed into the mash tun. And then, as I mentioned earlier, measuring the volume of the water that's going into the mash tun to get your ratios.
Hey, John, I made it back. My apologies for the technical difficulty there.
Yeah, I'll hand it back over to you. Where we're just we just got into the mashing automation.
All right. Well, sorry about that, everybody. I had a little computer issue, and I'm back. Kicking in here, and here we are on the mashing control. Just started catching a little bit of what John was talking about here. But when we look at the temperature control that's critical and how to actually control that, it's different for all three of the types of breweries. So on electric brewery, for changing the heat and stepping your temperatures, you have rims and herms. For direct fire, you're going to be looking at either direct heat. Some people will do herms. And for steam, you could do a steam jacket control. And with that, what we end up doing is controlling the volume of steam that is going into the jacket. So obviously you want a gentle heat going in, and as you do and step heat and maintain or step your mashes. So you definitely don't want to put a full amount of steam on the jacket. So all three of those are different ways that you can control and maintain heat in the mash. So timing is obviously another very critical aspect, and there's a lot of different ways to do the automation with that. There's different mash steps. Obviously, those are different times that you want to do the different steps. Maybe you're going to be 20 minutes, maybe only 15 minutes. So the controls here in the automation can be to automatically step through your mash temperatures at a certain period of time and do that automatically, or you could set the timer just to trigger that, yes, the operator needs to come back and make that change. So different options, but obviously timing is a very, very key part. You could also begin time and begin watering when you, we got a question there, but automatically switch over to the watering. So I have a question here on the Herms coil. with electric. Actually, not sure what the actual question is, so I apologize, but we'll come back to that. Sorry about that. It didn't come up on my screen properly. Circulation is another very big part of it, and there's different things that you could put some technology and automation behind. The circulation speed has a lot of effects on the mash. You want to get a good circulation going, not too fast. You obviously don't want to stick your mash. And also what you're looking for is to get a nice circulation so you can get a nice even heat. So that circulation becomes key, having a variable speed drive, perhaps even automating the different steps. So there's a lot of options on the circulation side. Sparging. So there's quite a bit you could do on sparging. One of the bigger things is to equalize the flow from the runoff to the sparge. So in essence, maintaining that liquid level. There's a number of ways to automate that. I've seen it done with sensors on level. That's one way to go. You could have a level that you set and dial in, I want to stick with that level. And the control loops would actually run those pumps at different speeds to maintain that level. Another more straightforward way is to actually run two pumps that are putting out the same amount of volume. You'll see that in the next slide. A peristaltic pump is a perfect solution for that, running at variable speeds. So basically, if you set your liquid level and you have the same amount of liquid coming in on your hot liquor and you have the same amount coming out going to the kettle, you're going to maintain that liquid level. So that's a nice way to do the automation. So here you see a picture on the right that just highlighted. That's the peristaltic pump I was talking about. They could be used for sparging. They're a nice way to go for sparging the hot liquor and then also emptying out into the kettle. I do have a question that did come up. And the question is, I step mash most brews. Should I set the hot liquor tank to 180 degrees to do the steps? 180 degrees is probably a little bit high. You have to keep in mind that when you're circulating your wort going through the Herms coil, what you don't want to have happen is that you start killing off the enzymes. Now, as soon as that wort hits the coil, it's going to cool off. So you're not going to have a lot of contact at that 180 degrees, but you have to be mindful of that. If you do get too high, those enzymes are going to start to deteriorate. So, thank you so much for that question, Mike. So back on the sparging, you want to monitor your speeds for sparging because you don't want to have any channeling as well. So if you're sparging too fast, you'll end up getting some channeling going on. It's going to be starting to flow through to one side or the other. So you have to be careful of the speed. So having that speed on there is a really good. The speed control is a really good method. And also you want to monitor the transfer volume into the kettle. So you could do that either by the speed of the pump. So that's one of those settings that you could have that you really keep an eye on and utilize from brew to brew. You could also put a flow meter in there. So if you do have the flow meter, you're going to know exactly how much volume you're going to the kettle and also what the rate is going into the kettle. Another really good piece of automation comes if you're using a grant. And if a lot of you have used a grant before, then what you'll find is that you're constantly turning the pump on and off or fiddling with valves to get that perfect flow out of the grant. Because the first thing you're going to do is set your gravity feed. You want that mash tun to just do its thing naturally. But where the automation comes in is to set up so that the grant empties without you having to be at the grant constantly throughout the entire sparge session. So what can be done there is you put sensors in to monitor that liquid level, and then you're going to vary the speed of the pump that's pumping out of the grant. So what we end up doing is we put two floats in there. One is a high level, one is a low level. So what happens is as it fills up, the grant will trigger that low level and that'll turn the pump on automatically, which is a nice feature because you do not want to run that pump dry. So in addition to getting a nice flow, you have to be careful. If you run the pump dry, you're going to start destroying and wearing out your seals. So having that low float to have it turn on automatically is a nice setup. But if you just have one float, what can happen is that you're going to turn that pump on and off pretty rapidly, which could also start causing some issues with the pump and the motor starts overheating. So if you have a second float, which is usually set a little bit higher, closer to the top, what happens is you start when it hits the bottom float, it'll go at a slow speed, and that liquid level will start raising up as you're pumping over. Now, if it hits that top level switch, then it's just going to kick to a higher speed until it gets down to the lower switch, and then it starts that cycle all over. That's a very nice way to handle an auto grant setup. Another piece of automation is that you could take a look and monitor in line your pH conversions, pH levels, I should say. There are sensors that you could install into the tank in line as you're doing watering. So you could really get a nice idea of where the mash is, if it's done its job. One little word of caution though with the pH sensors is they have to be calibrated quite often. So, before every batch, you're typically comparing it to a known pH, and you have to do a calibration. So it's a little bit of a challenge, but it can certainly yield some great results if you have that information available to you. So we get to boiling and whirlpooling. One of the real major pieces of automation is having precise control over the power that's going into the kettle. And the reason is that it affects a lot more than a lot of folks realize. If you're not able to, some of the obvious ones, you want to be able to control your boil over to lower that heat. So if you're doing it with electric, we have PWM circuits that you can install that will automatically, or for boil over, automatically if you have a sensor, or manually adjust the heat output of the heating elements. For steam, it's going to be the same thing, but with a valve. We put an automated valve in there to control how much steam is actually going into the jacket. Some little word of caution there is that the reaction time on steam could be a little bit long, so you have to be early in predicting when that actual boil over is going to happen. Direct fire, same thing. If you have modulated controls on your burner, you can turn your heat down. So having that precise power control can prevent those boil overs. Also scorching. When you're filling up, if you have a very high gravity beer, your first runnings are going to be very, very thick, much higher gravity. So you have to be careful there that you're not putting too much power into the kettle because you're going to do some scorching. And that's in all three of those aspects, the electric, steam, and direct fire. But where it really comes in is the predicting the evaporation rates. So once you get a nice rolling boil, to be able to repeat your evaporation rate is very crucial. You're going to be looking at what your volumes are at the end. That's going to affect your final gravities. If you end up having to boil longer to get to that exact gravity, now you're going to have some more hop utilization rates. So having that number set and having that repeatable from brew to brew is very important. Electric is quite easy to do. You could set your percent output with that PWM I was talking about, and that will allow you to adjust that output to, as an example, 62%. With steam, it's the same thing. You have a valve that is open 0 to 100%. So if you open that valve to 42%, then you have that same volume of power, in essence, which is the steam going into the jacket to cause that evaporation. So the key is to be very repeatable in that process. Another thing is hop dosing time. That could be automated as well. It could be as simple as giving you remote alerts of when to, a little alarm goes off at a certain time to tell you that you can go ahead and put the hops in. I've also seen automatic dispensers that can automatically trigger that you're going to put your hop additions in at certain times. A lot of times that's going to be in your bigger breweries, but there's no reason that could not be implemented in a smaller craft brewery. So there's a lot of different things you could do for hop dosing. Obviously, your timing, monitor when to stop your boil at a set time. That could be automated, that when the time is up, you go immediately into a knockout. Another interesting part of automation or possibility is specific gravity monitoring. There are sensors out there that can give you a specific gravity, so give you some real-time readings so that you know exactly where you are during the boil. One of the tricky parts there is that these sensors are typically not rated for the boil temperature, so you have to, as it pumps through, it's going to go through a little cooling coil. But it's a pretty slick way to get some real-time specific gravity readings, and you can do some controls based on that. Getting into whirlpool speed, having a variable speed drive, automating and being repeatable on how fast you're actually doing your circulation. There's a lot of different formulas out there, but having that ability to say, okay, on this particular brew, I want to get a whirlpool going at X speed is definitely another parameter that you can control and automate. Getting on to wort cooling. So temperature control on wort cooling is obviously the name of the game there. And there's a lot of things that you can control and automate. When you're looking at the maintaining the plate chiller output temperature, there's a lot of things that affect that. Your flow of wort coming from the kettle. If you're going too fast, you're going to have higher temperatures. If you're going slow, you're going to have lower temperatures. The other part of it is controlling the flow of your water. If you're doing a single stage or water and glycol, if you're doing a dual stage, you can set your glycol at a set volume because that's going to be off of your loop. But you can control the flow of the water in order to maintain the flow of the wort. So if you're really targeting a 45-minute or 30-minute cool down, then what you're going to do is set your volume flowing through, and you can monitor that with a flow meter, or you can go ahead and do a loop on that. So it will automatically do the flow, but typically you want to have that flow be constant and then put the control loop on the water flow. And that water flow will be based off of the temperature probe that I have pictured there. That'll be on the output of the chiller. So your control loop runs in that way. So that's going to do a lot of things for you. It's going to maintain that output. It's going to reduce your time to pitching because you're going to make sure that you hold to that 30 minutes or whatever your number happens to be. Wort flow control, basically that's what I'm talking about is controlling that flow through the heat exchanger, get consistent knockout times, nice steady flow through a hop back as an example. If you're running very fast through the hop back, you may not pick up as many of the hop lipids. If you're going slow, that might be preferable. So that wort flow control with a flow meter can certainly give you a lot of valuable information. And of course, measure volume into the fermenter. So you want to know how much you get out of your batch and into the fermenter. That's where a flow meter can certainly help out. Oxygenation, you could certainly control the flow of the oxygen to the stone. There are different feedback sensors to, or I should say valves, to monitor and actually adjust that flow of oxygen. It's always a difficult thing to, with a needle valve or how you do inject it when you're coming out of the chiller and through an oxygenation stone, is to get that just right. And typically it's done by hand and visual. That can still be done, but there are definitely sensors that you could utilize to create a control loop. And a lot of times that's on some of the bigger breweries, but again, the technology is there and the costs are not actually too far out to actually do that and get repeatable results for injecting oxygen. Obviously having control over that, you're going to control your quality. Over oxygenation, under oxygenation is going to cause you issues. It's going to save on your O2 usage. Then we get into cellaring. Cellaring automation, there's a lot of different things you can do. Obviously, the temperature is one of the big ones. You want to, if you have your jacketed tanks, which typically would be for anything over a 2-barrel, you're going to control your temperature by turning on and off your glycol flow to the jackets based on the temperature that you're measuring in the system. But there are different things you could do with that. A lot of folks want to do a feedback loop in order to ferment at different temperatures at different times, get some different flavor profiles, et cetera. We've actually even taken a look at changing those temperatures based on how quickly you are actually fermenting. So if you're starting to ferment too fast and we're able to sense that with a pressure sensor, we could actually lower that temperature in order to control the rate of fermentation. So there are several control loops and some things that we've been working on that can really put a lot more technology and automation into the cellaring controls other than just maintaining one temperature. So timing, scheduling and monitoring fermentation temps. If you did want to step it, you're going to want to take a look at the timing, automatically make it switch over. Lagering schedules are very important for that. So if you're making a lager, you're going to want to make sure that you kick down into your lagering temps, and then of course monitoring how long that you'll be doing that doing diacetyl rests, all of that could be automated. Hop dosing can be done in different ways. You could add some automation to that where you're going to hop dose using some CO2. If you have a hop doser, that it'll automatically kick the CO2 on, open a valve, and dump the hops in for you at a particular schedule. Some pretty neat things you could do there. Record keeping. Keeping record and logging data can certainly be considered automation. If you're maintaining, your actual temperatures, taking a look at your temperatures, looking at, did you hit the temperatures? Did anything happen? If you start really getting a fermentation that is running a little bit too hard, it's going to increase your temperature, and maybe the glycol chiller is not going to be keeping up with that load. You can identify some issues there. So record keeping becomes a very nice automation feature. And another one that we've been doing some work on is monitoring the stages of fermentation. We've taken a look at using, I mentioned a little bit before about monitoring the pressure on a fermenter. And we could look at the changes in the pressure as it's actually going through an airlock and determining which stage the fermentation is in. So that's a pretty interesting, an interesting technology and automation that opens up a lot of different doors. So it's a very interesting and powerful tool that comes into the automation portion of things. So how you automate is obviously up to you. There's a lot of things to consider. I just went through all sorts of different things, and it doesn't mean that all of them are for you. There's different ways to approach these controls, different ways to implement automation. So as an example, you could go with a very basic type control panel. In fact, you could even go more basic than what we're showing here, where you can have individual controls on different tanks. So it could just be, Johnson controller, et cetera. And that's automation. So you have to kind of take a look at what your goals are, how far you want to take it. When we look at a basic control panel like this one here, it does take care of necessary automation requirements. It'll do the hot liquor tank temperature control. It can do a RIMS control or HERMS control, give you that output. You see the knob there for the output for your kettle. So it'll take care of a lot of the necessities. And a lot of times it can also be expanded to include, valves and valve controls and things along those lines. It does allow for a more hands-on brew day. Some folks like to actually hit switches rather than push on a touchscreen. So, and it's also a budget-minded control technology. So you can go with more basic, and there's absolutely nothing wrong with that. And then the other side of things is you can go for a little bit more of an advanced type system. So there's really, the sky's the limit when you're looking at PLC controls. You have an endless automation potential. We hit on all sorts of different points, but there's setups that you could have everything on automatic valves, whether they're pneumatic valves or they're electrically actuated butterfly valves. The entire process can certainly be automated. And again, with the craft, sometimes or all the time, it's that balance of how far you take it and how far you want to maintain some more of the hands-on decisions as you go through. So again, endless potential. Got to consider data collection. If you want to have recipes, which is very nice to have when you're talking about repeatability. Remote access is a very big one, so that you could actually dial in and see what your system's doing. Perhaps you're not the brewer, you're the owner, and you want to make sure that your brewer is doing the job that you're hoping that they're doing. You could certainly set up a system along those lines. John was probably explaining the hot liquor tank timer. If you wanted to set that timer, or you say, okay, you wake up at 5 o'clock in the morning, you could dial in, set your hot liquor tank to turn on, and then get your way into work and then start your brew day. So it can certainly be a time saver. So all of this, it's expandable, and it allows the brewer to really multitask as they're going through the process, instead of like, for the Wort grant, hanging over the Wort grant and adjusting valves. You could have the automation take care of things and clean kegs or do the million things that the brewer has to do. So what's right for you? Well, as I mentioned here, no matter what level of automation you choose, you will certainly find that automation is a very important part of your brewery. gives you better control, higher repeatability, shorter brew days, certainly tons of cost savings depending on where and how you automate, a lot of different operator efficiencies, and better ability to do what you love, which is to craft some great beer. So I'm going to put my video back on here. Again, I apologize for the difficulty. My computer decided to do an upgrade in the middle of the presentation, so glad John was here to kick in. But I'm going to go ahead and try to get to some of the questions here. And
Kevin, one of the questions that came up was when you were talking about electric, steam, and direct fire, what the best choice is. And for those listening, we have a webinar on that tomorrow at noon Eastern time, but maybe you can give us a little preview of that one, Kevin.
Yeah, absolutely. That's always a question. You know, which one is a better technology, and you know, we are going to go through that. We're going to talk about some of the different items of the different benefits, pros and cons of brewing the electric, brewing steam, and brewing direct fire. So we have a pretty nice comparison on all fronts there. Since this is automation, I can kind of touch on that a little bit, where, you know, when you're automating one of those systems or all of those systems, to me, and again, it's my opinion, is the electric is easier to automate when you're looking at heat because you have very, very precise and immediate feedback control. Steam is very close. You're able to control that with your control valves, as long as you have those set up. You know, we use automated or motorized globe valves. Direct fire, it depends on how you set that up. If it's an on-off control, usually it's turning the heat on, turning the heat off, or if you have a modulating burner. If you do have a modulating burner, that could be very handy as well. So kind of a lot of pros and cons, but we'll definitely do a deeper dive into that when we do that. I'm not sure, when is that one, John, that particular seminar?
Eastern time tomorrow.
Excellent. Okay. So let's see here. We got a lot of questions. John, you want to throw me up a couple questions? Is that easy to do?
Quick one. What's the difference between PLC and PID?
So PID control and a PLC is what provides the different control types. So when you're looking at temperature and you're looking at an actual true PID loop as compared to an on-off controller, you know, those are really the two types. So let's just say in a hot liquor tank that you're heating up, you have it set for 165 degrees. With an on-off controller, as soon as it hits 165 degrees, it's going to shut off your heat. With a PID loop, what that's doing is it's doing a predictive control. So as the temperature is rising, getting close to that 165 degree mark, the system knows how quickly it's ramping up. So it'll start backing off on the heat so that once it gets to that 165, you're at the maintaining temperature, because that hot liquor tank is going to be, you know, giving off heat, losing heat at a particular rate, and the PID learns from itself and knows what that rate is. So it'll know, say, the output's going to be 60%, or it'll be kind of high. Maybe it's 40% to maintain that temperature. Then it'll be sitting at 40% just as you get to the set point, and it'll maintain it, so it'll prevent an overshoot. So sometimes a PID loop is a fantastic way to do the control. Other times it becomes a little bit too complex, and a simple on-off control would do the trick. So hopefully that answers the question. That's the two types. What else we got?
An option when it comes to automating?
Say that again.
An option on the automation controls.
Oh, absolutely. You know, we were talking about this recently on our side, and you know, it's any supplier really that, you know, allows for, you know, doing different customizations. We've been finding that a good majority of our panels lately have been customizations, and it may be something slight, and other ones might be something very, very complex, I guess you would say, something that's outside of the norm, but absolutely customization is not a problem. You know, that gives us great ideas and gets us a chance to get our R&D unit set up. So
on different types of sensor technology, and I'll wrap these into one. Ronald asks, have you incorporated pressure sensors for water levels? And similarly, Thomas asks, have you tried or tested reading density during the boil?
Yeah, so pressure sensors for level, I'm guessing that you're talking about more of a weight sensor. Well, actually, no, I get you now. Yeah, so pressure sensors can be used, and actually, I've done that in a different industry, but where you have the pressure of the liquid in the tank and you're monitoring that. You can do that. One of the tricky parts is if you're doing a circulation, that's going to, of course, throw off your pressure because you're getting a lot of movement in that tank. But no, that can be done, and it's an interesting way to think about it because that could give you a full 0 to 100% level detection, especially if you're looking at fermenters where you're not doing circulation. So yeah, absolutely, that is certainly a nice way to go. I was talking about weight sensors. You could also put on the tanks and get a zero weight before you put the material, which would be the liquid into the tank. So that's another method of doing level detection where you're not having a probe actually in the liquid. And in gravity readings, is that right on the kettle? Was the other question, John?
That's right.
Yeah, there's a sensor, and I kind of hit on that a little bit when we were talking that will actually measure the specific gravity of the wort in line, meaning that you actually pump a small amount through it. I hope I don't mispronounce it, but it's the Coriolis effect, where in a nutshell, what you're doing is putting a sound, an ultrasonic sound, or an ultrasonic vibration, I should say, across the sensor as the liquid passes through, and they're able to figure out exactly what that density is. And it's an interesting technology on the distilling side. We use it to find out, how much alcohol is actually in the vodka or whatever you're making in the liquor. But the same technology is used to kind of come up with the density. So on a kettle, the temperature levels, I think you have to be down about 185. That's off the top of my head. It might be different, but around 185, but certainly not boiling. But we found when we did some tests on that we just go through a small coil and that cools it enough that by the time it hits that sensor and then it pumps back into the kettle, you're below that temperature and you can get a reading. So yeah, that technology is there. Absolutely.
Daryl asks, are automation software platforms typically PC based, and can they be updated without a programmer?
Um, it depends on the control platform. The embedded type system is more standard in automation packages, meaning it's not Windows based system. As I experienced just a little bit ago, having a Windows based system can be unpredictable. So it knocked me right out of the conference here. So myself, I kind of shy away a little bit from the Windows environment because you have a lot. It's a lot of control that you give up. If there's bugs, you have to rely on the Windows platform and Microsoft to fix that bug, and then you end up kind of chasing that on the software side of things. But on the flip side of that, though, on a positive, I know it's used very commonly. So being on like a Windows PC platform has a ton of benefits as well because it makes it a lot easier to get into Excel spreadsheets and all sorts of different apps. So really on a batch type control, which the brewing process is, it's really not a bad technology. So those are kind of the two things to weigh. The question of being able to modify it yourself. I know there's suppliers that do offer out the code, and it's a very simplistic code to go through and try to modify yourself. But it's depends on what you're looking to do. There's also some Arduino boards and things like that you could kind of customize yourself. I know on our side that we're using the PLC ladder logic, and if you really didn't know that, it could be a bit complex, and you can kind of get yourself into trouble with trying to program it. So we're always wide open to making changes to the software. If there's a feature that somebody wants, then that's very easy for us to do. We have software folks on staff to do it, and that's kind of been our approach.
John asks, what is involved with adding additional equipment, such as fermenters, to an existing control panel? And does the level of automation affect your ability to expand in the future?
That's a great question. On our side, we we ran into that in the beginning where we would sell or provide 8-point panels. So in essence, you had 8 fermenters. And then someone would come back and say, okay, I'm expanding. I want to put another 2. And, we try to catch that in the beginning and go to a 12-point panel. But then, of course, the 12-point, and all of a sudden someone wants 14, et cetera. So it became a matter of, all right, well, if you had an 8-point, then we take the 8-point back and do a trade to a 12-point. But so that became obvious as all the smaller breweries started expanding and really brewing quite more often, and finding the capacity was in the fermenters. So we were having a lot more than 8 points and even more than 12 points. So what we do on our platform, and I'm not sure, I think others do it as well, we do modules now. So everything is module based. So what we'll do is provide an 8-point panel. This is on the PLC ones, by the way. So you have an 8-point panel that would be up in the ceiling, controlling the valves and temperatures inputs. And once you go beyond 8, you just simply add another one, and that gets daisy chained in with that control loop. So it's basically just an internet cable, network cable going from one panel to the other up in the ceiling. And that really works out well, because if you had one panel that had 20 some odd tanks from it, you have a lot of wires that are running all over. But being able to place each one of those in the cluster of 8 fermenters or bright tanks really becomes handy. And I think we've probably the most we've networked so far is about, I think it's 5 of them. And that's a lot, but it was an interesting project. But yeah, and not only that, but expanding to other things. So as an example, if you're going to add a filter press to your system, and you already have a PLC and you want to add that, we have a module for that. So it's not a whole new system. Basically, it's a module that's going to accept the inputs from the sensors and take care of the outputs to the valves. And then you could actually add something like that to the system. So going with that module approach and the PLC platform that we use becomes very easy to expand upon. Okay, question came up here. Which PLC do we use? Well, I tell you, we use Unitronics, and just a little bit of a background on that. I mean, I kind of grew up in automation as a PLC guy from Allen Bradley. The Allen Bradley controls are amazing. To us, though, they're a little bit too expensive for what they do, and they kind of a lot of there's a high level of charging for software and upgrades and things like that. But and I love the product. There's no two ways about it. To us, though, the Unitronics was a nice fit because it has all the power and then some that we could ever use, and the price level is very, very reasonable. So we know that we have to hit a particular price point on our products and make it so that the automation is achievable and purchasable for these small systems. So so we decided to go with the Unitronic system, and we've been using that forever. And they have great warranties, although we don't have to use them much, which is good. And they have great support. So yeah, we use Unitronics.
Question here, Mike asked about glycol controls. Is it just as simple as a temp control for each tank and a solenoid valve?
Yeah, that's the typical way. We put a solenoid valve or a motorized valve on the glycol loop. So you're going to have a first in, last out on the glycol loop. And when it calls for temperature, it's going to open the valve. When it reaches your temperature, it's going to close the valve. You could also do, and we've done this as well, you could actually do more of a PID type loop. So that would be a variable position valve. So you're going to slow the glycol flow or speed up the glycol flow in order to maintain the temperature. To me, the on-off control really gives you a tight control just based on the volume. So in my opinion, the on-off for that level of and size for the sizes that we're looking at as far as the craft brewing really does a nice job, and it doesn't really warrant having to do PID loops. Once you start getting into bigger tanks, we're typically putting in not just the one, but say you have 3 zones, we can control all 3 zones. And sometimes that becomes pretty handy because you might end up changing those temperatures of the different zones so you can get some nice circulation action going on. As you allow it to warm up in the bottom, that wort's going to raise to the top. What's being cooled on the top is going to go to the bottom. So you're going to get that circulation going, and that's great for hop utilization. So if you have multiple zones, then even though it's still on-off control, you have control over the different zones there. So it's a pretty slick way to go.
The last couple questions here are about gravity sensors. Corey asks, what kind of gravity sensors exist? And another question is, do these sensors need to be calibrated frequently, like the pH sensors?
There's different types of them. That Coriolis one does not need to be calibrated, and that would be the one that I would always take a look at. Temperature does take a play in there, and that what they have temperature sensors built into them. So there's a little loop inside of these units that do a self calibration based on temperature. As far as any other, there's a number of different ways that people have come up with for gravity readings. One of the other one, not necessarily a gravity reading, but kind of let you know where you are in the fermentation process, is to look at the pressure and to find that change of pressure, kind of that shift in pressure, I should say. Even as you're exhausting out of talking about a fermentation here, but exhausting out of the airlock. So you kind of get those bubbles that are happening, and we could see the transitions literally on every one of the bubbles. And we can correlate how quickly you're fermenting, and from there determine when you shift the phase in the fermentation. So there's another way to do it without an actual sensor, that shows a lot of promise. It's kind of the same as like if you're looking at your bucket, which you always do when you're fermenting. Hey, when did I start fermenting? Well, you look at it and you see a bubble. You say to yourself, well, I must have started fermenting just then and there, but it could have happened 6 hours ago when you were sleeping, when you first started getting activity in the fermenter. So when you kind of look at that pressure, you could say, okay, exactly when the activity started in the fermenter. And then also as you're fermenting, when you hit your peak, when you come off of the peak, all of that could be recorded based on these pressure readings. So I kind of got off on a little bit of a tangent there, but it's kind of a neat way to go about it. Another question came up here. How have you handled heating fermenters? Yeah, that's a great question. One of the ways to do it would be to have two zones in the fermenters. This is kind of an easier way to do it, where you'll have, let me make sure I get this right. The upper one will be your cooling, and your lower jacket will be the heating. So when you're cooling, you're just going to be running that loop, and then when you're heating, you're going to be running the other loop. So you're actually heating and cooling in the two sections. And the reason I'm suggesting that you do it that way is because you have your cold loop coming from your glycol chiller, which may even be doing cold rooms, whatever the case may be. So if you have one fermenter you want to heat up, you don't want to heat up all of your glycol. So what you would do is have a separate heated tank that will be heating the glycol, and that would be another loop that you would run in order to get your heated side. That's kind of the way we've done that before, and it's very effective. We even do something similar to that when we get into the distilling side of things, where we're heating and cooling and mash tuns and everything else. So yeah, nice question. Thank you.
I think that's all the questions. I think we got to them all.
Did we really? Okay.
So one last question came in. Electric system. Is there a way to estimate the amount of kilowatt hours consumed before your brew day?
Yeah. Yeah, it depends. I do have a lot of people ask us, what their cost is going to be of running an electric system. We do quite a few of those, so that's a question that comes across the desk quite a bit. So we have a spreadsheet that we take a look at and say, okay, well, if you're going to be doing a 60-minute boil, et cetera, type in a couple other knowns. It's very easy to predict because, kilowatt, really relates to BTUs, and kilowatt hours relates to time. So it's a pretty simple spreadsheet. So you can definitely, understand exactly what your kilowatt usage is going to be, and then what your cost is going to be. We do that analysis a lot to, take a look at the comparison between electric, steam and gas, natural gas for direct fire. And, it depends. Like as an example, if you're in the Caribbean or something like that, then your electric rates could be very high. And that wouldn't make sense. So a lot of times, direct fire or steam makes a lot more sense that way. Here we've done the calculations in New York where we have a decent, decent rates, a little bit higher. I mean, we're not in the city, we're an hour and a half north of the city, but at kind of average electric rates, it becomes a little bit of a wash between electric and steam, because electric is 100% efficient almost, because you're direct, the elements are directly in the wort. Where steam, you're looking at 80. If you have a high efficiency, you're going to be higher than 80%. So that kind of becomes a wash. A lot of times, steam will beat out electric just by a little bit. So they're very comparable. Direct fire, there's a lot of heat loss, so that certainly becomes a higher energy user, but definitely on cost. When you look at propane, direct fire becomes very expensive. Kind of got off again on a little bit of tangent, but I did have a couple minutes. So, any other questions come in, John?
That's everything.
All right, well, that's fantastic. I see we have quite a bit of attendees from all over the place. I want to really thank you for coming and attending this one. Hopefully, you're going to get to a whole bunch of uh, the other seminars. When we finish this up, you're going to actually get bumped over to another screen that's going to allow you to schedule some one-on-one conversations, and see some contact information up on the screen for myself, Michael O'Neill, JB and Whitlow. We're all part of the Brewmation team here. So feel free to shoot us an email, and if you want to have a one-on-one and talk about particular automation ideas that you have, basically anything, feel free. We had this week blocked off to be in Texas for the CBC, so we'd love to reach out and chat with everybody that we can. So feel free to go ahead and use that tool and schedule to have a chat. Look forward to talking to you. Thank you so much.